and welcome to part 5 on my series on producing robust programs. Today we're just going to have a short video on maintenance and why it's important. Apart from the very simplest programs, it's unlikely the program will ever be error-free in its first version, so revisions will need to be made. Over time, the requirements for a program may change, and the program may require some modification. Therefore, programs need to be well structured and documented to ensure that they're easily maintained. So at high school or possibly university, you might be the only person working on your programs. Often they'll be quite short, and you think, well, why do I need to worry about this? I know what it does. But as your programs become more and more complicated, and as you start working on programs that other people have written, or other people have to work on programs that you've worked on previously, you'll start to understand why this is really important. It's easy to forget what software does, and it's especially difficult to figure out why other people have made decisions that they have in their own coding, unless there's a way of finding out. So to make sure that your code is maintainable, there's a simple kind of checklist of things that you can do. So for example, indent the program structures in your code. So that's things like for loops, while loops, ifs, else ifs. If you program in Python, you have to do that. Other programs, you don't have to, but you should. Of course, you should always add comments to your code to identify what each section does and how the program is intended to work. So it doesn't mean you need to comment every single line of code, but each block of code, each subroutine, each procedure, each function, each for loop, each while loop, a little bit of code just to explain what's happening is really helpful. You can also use meaningful variable names to help identify the purpose of each variable. It's very easy when you're kind of starting code to do something like, I equals I divided by j multiplied by k, because it's 3 lines of code and you understand what all these mean. But if you've got a program that's 1,000,000 lines of code, it can take ages to figure out what all these mean. Don't do it. Give them proper names. Another thing you can do is use white space to make the code easier to read. And that just means adding gaps between blocks of code, laying it out so it looks nice, just makes it easier to read and understand rather than cramming it all together. You can also keep logs showing that the tests that have been carried out and the results. This makes it easier to find bugs in future, because the person who's looking at the code, which might be yourself or somebody else, can go back and say, right, well, I've already checked all these possible sources of errors, so I can not have to retest those. I can just have a go and try and figure out some other tests to try and find the error. So again, I'll give you an example of this. We've got some code here. I've just randomly chosen from a colleague's code. This is not mine, but just a colleague that I work with, a program they've written. I've just taken kind of a screenshot of part of it, and just to show you that generally they are following this advice. So they're using meaningful variable names like guess, there we go, or letter, or blanks. They're doing a loop using I, that's kind of okay. I'd probably still use count or a loop, but generally most of the variable names are pretty sensible. They've got lots of comments. You see, you've got a comment here and here and here and here, just explaining what the code does. Again, it's Python, so they have to indent all the loops and conditions correctly. But again, even if you don't have to, you should always try indenting all the code just to make sure it's easy to see where things start and then where they end. So again, just a piece of code here, random screenshot. But again, just using good techniques to make sure it's maintainable and understandable when that person comes back to look at it in a year, or if the students look at it for an example, or if somebody like myself, another teacher, wants to look at it, just as I can read it easily and I can understand how and why it works. So that's enough on that. As I say, that's just a quick video on maintenance. I will go away and prepare the next video, and I will see you shortly. Good luck with your studies.